Objective of this experiment is to determine the dielectric constant of the material used in the given capacitor using the method of charging and discharging. Formula to find the relative permittivity is as shown. Epsilon R is equal to 1.443 into 10 power minus 6 into T half into D divided by R into epsilon naught into A. Here epsilon R is the relative permittivity, T half is the time required for the capacitor to charge the value half of its maximum value, where D is the thickness of the dielectric material used, A is the area of cross section of the capacitor plates, R is the resistance used in the circuit, epsilon naught is the permittivity of free space. Apparatus required: digital stop clock, digital voltmeter, resistor, capacitor, stop clock operating knob, stop clock reset button, charging or discharging knob. Circuit diagram is as shown and the circuit connections are made as shown in the figure. Once we perform the experiment, the nature of graph is as shown. The graph is plotted potential difference, that is voltage across the capacitor versus time. Circuit connections are made as shown in the figure, that is the positive end of the battery is connected to the circuit and the negative end of the battery is also connected to the circuit. Resistor is connected to the circuit. Here we are using 100 kilo ohm resistor. The capacitor one which we are using in this experiment is a polarized one. Hence, the positive end of the capacitor should connect to the positive terminal and the negative end of the capacitor should connect to the negative terminal. Across the capacitor, we'll connect the voltmeter in order to calculate the potential difference. The positive terminal of the voltmeter is connected to the positive and the negative terminal of the voltmeter is connected to the negative. Make sure the connections are made as shown in the circuit diagram. Circuit is switched. Make sure the stop clock initially reads 0. The stop clock on which we are using has a range of 0 to 100 seconds. Digital voltmeter measures the potential difference across the capacitor. Make sure the charging and the discharging knob is turned to charging mode. Make sure the potential difference across the capacitor is 0. Now the experiment begins. For every 5 seconds, the potential difference across the capacitor is tabulated. Like for 5 seconds, 10 seconds, 15 seconds, like this till 50 seconds, we will note down the potential difference across the capacitor for every 5 seconds. Once it reaches 50 seconds, switch the knob from charging to discharging. Then note down the potential difference across the capacitor for every 5 seconds in discharging mode, like 5, 10, 15 till it reaches 50 seconds. Note down the potential difference across the capacitor for every 5 seconds. Readings are tabulated and potential difference across the capacitor versus time graph has been plotted. The charging curve is represented by blue and the discharging curve is represented by saffron. These two curves meet at a point. That point is marked and a line is drawn in such a way that it meets an x-axis and the corresponding value is tabulated. For the experiment we have performed, the t-half was 7.5 and it is substituted. The thickness of the dielectric material is given, that is 0.075 into 10 power minus 3. It is substituted. Corresponding resistance value is substituted. Permittivity of free space is substituted. Area of cross section of the given capacitor is calculated and substituted. The calculation is simplified and the answer was 3.901. The outcome of this experiment is we have determined the dielectric constant of the material one which is used in the given capacitor. The dielectric constant or relative permittivity one which is used in the capacitor is equal to 3.901.